In this topic 11, part 2, we look at some rules that help us integrate more complicated functions. These three are the same rules but in reverse as we looked at with differentiation. If we have, say, the integral of 3 times x squared, then we can take that 3 out the front and do the integration that way. If we have, that's terrible, that's a 2. If we have two functions that are added together that we need to integrate, we can just split them up and add the separate integrands. And the integral of k, so the integral of 3, is, following this last rule, is 3x. Don't forget, plus c. To integrate a long sum of things then, we need to integrate each part separately. Now, I don't think in your list you'll have the integral of the natural log of x. This one's just a little bit special, so you just need to remember this, and maybe you can write it on your textbook or certainly in your notes, that the integral of the natural log of x is x natural log x minus x. So that's something to learn. Otherwise, you find the integral of 25, which is 25x. This one, the next one is 2 times natural log x, so it'll be 2 times all of that, plus the integral of 3x squared is x cubed. The integral of e to the 4x will be 1 over 4 e to the 4x, and don't forget plus c. To integrate these, the first 4, you need to rewrite them as power statements, except of course where you're looking to integrate 1 over x, because the integral of 1 over x, integral of 1 over x is the natural log of x. When you come down to number 5, you need to multiply out first, because we've got no rule in this course at least for dealing with products, so you need to multiply it out first and then integrate. In number 6, before you actually do the integration, it's pi r squared minus pi x squared. And now, thinking about that, to integrate pi r squared, that's a number like 3. So the integral of 3 is 3x. So the integral of pi r squared x is pi r squared x minus, now you're only integrating the x bit, so you're going to integrate x squared, which is 1/3 x cubed, but it was multiplied by pi, so you need to multiply your answer by pi. And the last one, again, you need to multiply it out carefully, expanding the bracket squared carefully, and then integrate from left to right. The integral of e to the t is e to the t, the same as the derivative of e to the t is e to the t. It's one of those really, 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 really clever numbers that the integral of itself is itself. So first one's fine, the answer is just et. The second one, take the half in front of the integration sign. This pen is just not really working. So then you've got e to the x plus e to the negative x. And then it becomes straightforward to integrate. The integral of e to the x is e to the x, and the integral of e to the negative x is negative e to the negative x. Number 3, put the 2 in front of the bracket and then integrate e to the negative 3x. So that would become 2 times. Now, the integral of e to the negative 3x would be negative a third e to the negative 3x. You would probably want to leave it. You probably would want to tidy it up and make that negative 2/3 e to the negative 3x, but that's fine. The next one is going to take maybe a little bit of a guesswork. If you think about what you're doing, and remember you're asking yourself what differentiated to give us that, you'd probably want to at least start off with 1/2 e to the 2x plus 3. And then check. That's how you know if you're right. You can check backwards, differentiate that, and if you can differentiate a half e to the 2x plus 3 backwards, you should get e to the 2x. These you need to learn. In the exam, you'll be given the integral of cos x, and you'll be given the integral of sine x. So the integral of cos x is sine x, and the integral of sine x is negative cos x, but you are expected to remember what happens when you have ax plus b or something else, some other numbers, that the integral of that is 1/a sine ax plus b, and that the integral of sine ax plus b is negative 1/a cos ax plus b. You need to learn those. You're often asked to integrate sine squared or cos squared. What you need to remember there is how to do it, because you're not going to find the integral of sine squared in a list. What you need to remember is that sine squared is actually equal to a half of 1 minus cos 2x, and then you do it that way. Then you can integrate those. Same with cos squared. Again, you need to remember that a trig identity is involved, and that cos squared x is a half 1 plus cos 2x. Now we're going to use integration. We're going to use it in dynamics, just as the same as we use differentiation in dynamics. The first question says find the velocity. Now the velocity is the integral of the acceleration. Now if you look in the question, it's given you the acceleration. It's telling you that the acceleration is negative 3 meters per second squared, so that the velocity is the integral of negative 3t which is negative 3t squared over 2, and don't forget plus c. Now, normally it doesn't matter, but in this case we've got enough information to allow us to find c. It tells us that when t is equal to 0, then the velocity equals 25 meters per second. Okay, so that means that we can put 25, so 25 being our velocity is equal to negative 3t squared over 2, but t is 0, so that term goes, equals c. So c is equal to 25. So that means our velocity function is negative 3t squared over 2 plus 25. And you're then asked to find what is the velocity after 4 seconds. So now we've got our velocity function. We know that t is equal to 4. So it's just a matter of substituting t equals 4 into our velocity statement, and we get velocity is equal to 1. Now the second part of the question says, how far is the object from the origin after 6 seconds? How far implies distance. So s or x or whatever you want to call it is now the integral of the velocity. And our velocity function is negative 3t squared over 2 plus 25. So the integral of negative 3t squared will be t cubed over 2 it'll be negative t cubed over 2. So negative t cubed over 2 plus 25t plus c, or plus k, doesn't matter, some other constant. Now, what do we know? We know that when t is 0, the distance is 0. So when t is 0, x is 0. So that also means then that k is equal to 0. So our distance function is then negative t cubed over 2 plus 25t. I don't know why this pen doesn't work. There we are. Okay, now we need to put 6 seconds in there. So when t is 6, we can work out the distance. So when t is 6, the distance is 42 meters. So the answer for the final part, with as little writing as I can do, is 42 meters. Okay, we're given the velocity and you're asked to find the distance. So the distance function is the integral of the velocity function. So it's the integral of 3t minus 4. And if we work that out, that's 3t squared minus 4t. It's 3t squared over 2, if I could write it, minus 4t plus c. Now you need to work out what c is. Now look in the question, it says the object is initially 5 meters to the right of a reference point O. So what that says is that when t is 0, so when t is 0, s is 5. So we just need to put that into there. So 5 equals negative 4t plus c. So c will equal 5. what is the position, or what do we have to do? It says, what is the distance after 6 seconds? So we now have a distance function that says 3t squared over 2 minus 4t plus 5 and we're just going to put 6 into there. So sub in 6 and we get 35. meters. Now, what is the position of the object relative to the origin when the body is at rest? Now, a body is at rest when velocity is equal to 0. So we've got a velocity function, so that means we need to find when v equals 0. So that means that 3t minus 4 equals 0. So then t is equal to 4/3 of a second. Now, that's not the answer to the question. The question says, what is the position when the body is at rest? Okay, that means we know when it's at rest. We know that it's after 4/3 seconds it's at rest. So we need to put that into the distance function. So when t is equal to 4/3, then the distance is going to be, we put it right back into our distance function, which is back up here. The distance then is 2.33 meters. In this question, it doesn't actually look like you're given very much information at all. It just says a ball is dropped from a height of 1 meter at the beginning of whenever, and you've got to find an expression for the velocity, you've got to find an expression for distance, and you've got to find the time that it takes for the ball to hit the ground. Okay, so don't we know anything? Well, yes we do. We know acceleration. We also know that velocity then is the integral of acceleration. And we know what acceleration is. We know that acceleration is negative 9.81 meters per second squared, so that our velocity then is going to be the integral of that. And the integral of negative 9.81 is negative 9.81 t. Don't forget plus c, because it's in these practical examples that c actually is important. But let's look. When time is 0, what's the initial velocity? I need to think about that. When time is 0, we are dropping this stone. We're not throwing it, we are dropping it. So if we're dropping it, its initial velocity is 0 as well. So that means that c must be 0. So our velocity is simply negative 9.81 t. Like that. That is the case that you'll find that with anything that you drop, that it's negative 9.81 t. Now it says find the distance function. Okay, the distance function is the integral of that. Okay, so the integral of negative 9.81t is negative 9.81t squared over 2. Don't forget plus c, or maybe plus k since we've already used c. Like that. Now, we need to find k because this is a practical example. Let's look at the information that we're given. It says that when t is equal to 0, the distance is equal to 1, because right at the start, this thing that we're dropping is a metre off the ground. So when we start, t is 0 and s is 1. So if we put 1 into the equation above, then we can find that k is equal to 1. Because t is 0, so we're putting that into there, and t is equal to, sorry, k is equal to 1. That means that now our distance function, if I can write it or not, that s is equal to 1 minus 9.8 t squared over 2. What does the question say? The question says, what's the time taken for the ball to hit the ground? The ball is going to hit the ground when the distance is 0. So we've got a distance function that says 1 minus 9.8 t squared over 2. So when it hits the ground, that's got to equal 0. So 0 has got to equal 1 minus 9.8 t squared over 2. And if we solve that, then we get that t is equal to 0.452 seconds. So that's how long it takes for the ball to hit the ground. Okay, from the previous question, we know that the velocity is going to be negative 9.81 t plus c. Now, what do we know? We know that when t is 0, when t equals 0, v equals 10. So we can put 10 is equal to negative 9.81 t plus c. That tells us then that c is equal to 10. So our distance function is going, sorry, our velocity function is going to be 10 minus 9.8 t. Frustrating in the extreme. Right, so the velocity function is 10 minus 9.81 t. Okay, part B says find the distance. Right, the distance is the integral of that. So it's negative 10t. First 10t minus 9.81 t squared over 2 plus your constant, let's call the constant k. And do we know anything else? Okay, yes we do. We know that when the time is 0, the height is 50. So 50 has got to equal 0 minus 0 plus k, so k has got to equal 50. That gives us then our distance function. That would be 10t minus 9.81 t squared over 2 plus 50. And the distance function will be in meters. Now it says find the time and the velocity when the stone hits the ground. Okay, what do we know when it hits the ground? When it hits the ground, the distance is 0. So we need to solve our distance function equal to 0. So it's actually a quadratic. It looks a bit rude, but it's a quadratic. And if we solve it and just look for the positive answer, then t is going to be 4.371. The other answer is negative for time, and it doesn't matter. Now, that's the time that it takes to hit the ground. Now, we're also asked to find the velocity when it hits the ground. So now we have to put 4.371 back into the velocity function. And if we do that and find the velocity of 4.371, then that means we're going to put it back into our velocity function, which is 10 minus 9.81 t. We're going to put in there 4.371, and if we work that out, that becomes, using our calculators, negative 32.88. And it's meters per second. Now it's negative, that simply means it's going down. So there's nothing fancy about that.